So we start by logging in and create a new application. Give it a name, new multi-tier 1 in our case, and give it a description. Everything is versioned, so we need to save version 1.00, give it a description, and we create a new blueprint. So the first component is to drag a CentOS Linux backend database server template to the right. I give it a name, mysql DB server in this case, and also set the host name to be the same. I'll configure some default vCPU and VRAM entitlement, and then I look up the mysql out-of-the-box application service, and I drag it onto this instance. I also change the name to mysql instance. This out-of-the-box template also contains logic for setting the root password, the DB server port name, and things like that, but I will add a custom step later on, so we will be able to define a new database name, user, and password. So I drag a script and I give it a name. I use setDB remote. I will add some other stuff as well. So as I want the script to start after the MySQL has been deployed, I drag the anchor from the script towards the MySQL instance. So the script will only kick in after the MySQL installation has been finalized. Like this. Okay. And then we added the properties. Remember, we want 4 things: a DB name, a user ID, password, and also the IP address of this database server, and we will pass this to the Windows server later on. So I define a property of type string, and I give it the default name IDB1. This will be the database name as it will be created. I create 2 other properties for both the username, also of type string. I give it a default value neo as a username, and a password value. I give it the default password VMware uses everywhere in its online demos, VMware 1!, and I also set it to be secured so that later on in the editors the password is hidden. Now for the IP address I want to pass on to the Windows frontend server later on. I bind this new property not to a blueprint value, but to the IP address that will be generated once the Linux server has been provisioned. And I do it like this. Bind it to another property in the blueprint, and the self nic0 IP address is the actual IP address once the Linux server will be deployed. So now all the properties are defined. We can use them in the action scripts of this setDB remote. So the first action is to set the database to be remotely accessible. We need to pass the IP address of the server into a configuration file called etc under the etc directory my.cnf. So I do it by this command. I need to add bind address and the IP address, so I pass the var IP variable into this value here, and I want to write this line to this configuration file. That's it for the first step. Now, in the configure part of my my setDB remote script, I want to create a database instance with the name, the username, and the password. I've defined the properties where the user will also be able to change it later on in the wizard. So here is the command. The password is VMware 1! For the root user on the MySQL. So this is by default. And here I define create a new database, and I use the input parameter from the dropdown, the DB name we created earlier on, and that's it for the database name. With the second command, I grant access for the new user, and this password to this database instance name, and I also define it with the add and the IP subnet range. It will only be accessible from hosts that are in a specific 172.22 range. And we finalize by saving our activities so far. Now remember, we want a Windows front-end server that will be able to connect to this MySQL database backend server. So I create a new version of my blueprint, call it 1.1, give it a description, and continue. So next step is to drag a base Windows 2008 template onto the canvas and define the name, front SRV in our case, for both the name and the host name, set some default CPU and VRAM entitlement. Now, as our Windows server need some protection, I drag the antivirus McAfee application service onto the Windows instance, and also a native SQL client, so that if the Windows server gets provisioned, the user logs in, he can connect directly to the MySQL database server backend and test the installation. So the next step in our provisioning is to create a document on the Windows Server desktop with the username, database, and instance name and IP address of the backend database server, so a user can directly connect to it without having to go through any console. So we drag a new script task onto the canvas and we make it dependent to the MySQL instance on our Linux database instance, of course. So I rubber band and anchor again. We change the name of the script to something meaningful, get db info in this case, as we want to retrieve the input parameters from the MySQL database server and use them in the script on the Windows server. So I'll continue to add some properties and I'll map them to the values of the input properties from the MySQL database server, such as db name mapped to the db name from the MySQL server, same for username and password. So let's start by creating the db name property value on the front server, and we will bind it to the db name property on the MySQL database server. So my application director can directly pass this value from one node to the other, and we'll be able to use this input property in the script on the front-end server, which is our goal. We want to write all the values to a document on the Windows desktop. I do the same by mapping the db username and password to the values of the db Linux server, and for the IP address. So here is the result. All our properties are mapped to properties on the MySQL database server backend. Now we can use them in our action scripts. So in this task script, I will use Windows command scripting to write some values of the blueprint and runtime environment variables to a text file on the all user desktops. So the database server IP address, so that the user will know where to connect his SQL client to. The DB name, as set in the wizard. The DB username and also the DB passwords. I use the echo command to easily write those values to the same text file. So this text file will be at the end of the provisioning created on the Windows user's desktop. So we finish our blueprint by saving it again. The last step to be able to deploy this as a normal user role is to create a deployment profile. So we go back to the correct application version and we create a deployment profile, giving it a meaningful name. We then have to, in the step 1 of the wizard, map it to correct runtime deployment environment. I only have one here. I can review the details, so the real logical templates that point to the cloud templates of both VM entities. And as I have multiple networks in my vCloud Director backend, I select the correct network to connect those instances to. So we have a representation of both nodes, the Linux and the front-end Windows server, where I can override the blueprint values for all the input properties. So I change here, for instance, the VM memory, and also for all the application services. Here I can set the db root password to VMware 1 exclamation mark. And in the application component, remember both scripts we have inserted, I can now set the default db name, username, password I want as part of my provisioning later on. So I change it just to showcase. I can override it here. So this will be the default when the user deploys it. I leave the new and the password. In the next step, we are presented with the execution plan. So I can clearly see how the nodes will be deployed, the Linux and the Windows server in our case, how each step will be provisioned, all the application services, and I can review all the scripting and details behind each step if I want to. And finally, we get a global overview of all things we've seen before in the overview. And we're ready to save this execution plan, deployment plan for use later on.